And welcome everybody to the Daily Space Weather. Not only do we have massive plasma filaments peppering the Earth-facing portion of the solar disk, we've got rapid sunspot growth and a new sunspot rising in the northeast. We'll cover that and lots more on today's Daily Space Weather. And by the way, thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. Let's head back down to this massive plasma filament. We've got some plasma filaments that are looking more and more unstable as time goes on, thereby increasing the probability of additional coronal mass ejection activity. Sunspots setting in the west and rising in the east increase the probability of large solar flares, as sunspots seem to have a tendency to make a grand entrance and a grand exit. Does it have to do with the anisotropy of solar flares, meaning that they appear at a different intensity depending on viewing location? We've also got a huge, very unstable-looking plasma filament in the northern hemisphere. You can see this waving around. Part of it is anchored near this sunspot group, although it does extend vastly beyond that area. Here's another crown prominence up at the northern hemisphere. That is sort of the other end of that massive filament, and it is stretching all the way around the north heliographic polar region. Again, we've got a bunch of setting groups in the western limb, and as those set, those do become more likely to be associated with large solar flares of, M and possibly X class. You're also going to see significant increase in umbral area. In other words, sunspots have grown here and down here in the past 24 hours. Huge plasma filaments dancing there across the solar equator as well in the west. So lots going on. While certain hack frauds on the internet are telling their viewers that the sun is shutting down. A complete fraud that could not be further from the truth. There's the southern heliographic region. Again, you can see plasma filaments down there. A well-defined coronal hole of North Pole orientation, which we will show you additional detailed information on momentarily. Next, let's take a look at sunspots. Again, we did see rapid growth up here, right around the equator, and down here in the southern hemisphere. Also, this new sunspot rose in the northeast. You may be able to see that better on the colorized magnetogram. So there's the colorized magnetogram. And before we take a brief moment looking at volcanoes and planet Earth, please take a moment to remember and honor those who've served. So Memorial Day in the U.S. is a day to, again, honor and remember those who gave all. So a salute to those honored on Memorial Day. If you want to support the channel, consider doing so by becoming a member of the Smash team. You can find links on the homepage at smashomash.com, so check that out. If you haven't seen the homepage, smashomash.com, it was launched all the way back in February of 2019 when a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade to the internet underground where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the videos, maybe you can hire the Smash team. No, you certainly can. There's a link right there, as well as right there, a graphical link to the Smash team page. This video does include a paid promotion. It is our Hemp Lucid affiliate/sponsor, so visit the link below the video on that. Don't forget to enter the promo code SMASHOMASH to save 10% on your checkout. So Hemp Lucid, shop via our link, or just head to hemplucid.com, and when you've decided on what you're picking up today, enter the promo code SMASHOMASH on checkout. That'll save you 10%, and it'll help support our channel. Thanks to Hemp Lucid and those of you who have helped to increase the probability that these videos will continue to exist, remain publicly visible, and free for all to view. Again, enter the promo code SMASHOMASH to save 10% on your checkout for your lovely Hemp Lucid order. Today's featured product is the Galactic Federation Special Forces, because if you're sick of what's going on in your local area, well, expand to the galactic scale. Frighten your friends and foes with some Latin lingo and tell them that we said Universum Liberate, the official motto of the Galactic Federation Special Forces. So perhaps support their efforts to make the galaxy great again. Of course, now that certain people have brought peace to the planet, the Galactic Federation Special Forces is looking to bring freedom, liberty, and also peace to the galaxy. The symbolism represents signal security and integrity. Instantaneous galactic scale reach, the galaxy itself, and that bright bit you see in the upper right, that's classified. Convince your friends that you're in the Illuminati by telling them Universum Liberati. We've also got an Amazon shop. Check out our picks in there. Keep in mind we are paid commissions if you do purchase stuff through our Amazon shop. And if you want to support the channel via subscription services, consider becoming a member of the Smash Team. The best value is the gold annual paid-up subscription, smashomash.com/Smash Team. It's the official subscription services site of the channel. We are also still on Patreon and so on. Help us out on social media if you're unable or unwilling to open your cobweb-encrusted wallet and send us a few bucks per month to continue creating the content. Smashomash.com/Smash Team. And let's take a look at volcanic activity. We're wondering what's erupting, so let's cover it. Mount Ibu is producing a 7,000-foot ash plume. Luatolo producing a 7,000-foot ash plume as well. Popocatépetl exploding, flight level 210. That's a 21,000-foot ash plume over central Mexico. And let's don't forget about San Miguel in El Salvador. So that produced an eruption there overnight. Looks like a few hundred meters above the summit crater there are the emissions. Let's see if we can full screen that. It claims it's in full screen. Okay. Anyway, there is the El Salvadorian San Miguel volcano erupting. Also, Revenador exploding in Ecuador, producing a 14,000-foot ash plume. Sabancaya continuous emissions, no indication on the flight level there. And Nyamuragira in the Democratic Republic of Congo has been crusting up. It looks like the effusive eruption there has stopped, creating new real estate. Let's take a look at seismicity. There is the past 90 days. No major earthquakes over the past 24 hours. And thanks to Kimberly Nichols. Yes, Kimberly Nichols of northeastern Australia cited that her friend in Melbourne felt this 3.6 magnitude quake, so thanks for letting us know about that. We will cite quakes over a 5 magnitude like this 5.1 at Papua New Guinea that came through at 12:52 Universal Time yesterday afternoon. There was also a 5.3 at Columbia. That was at 15:45 yesterday afternoon. The Pacific Antarctic Ridge had a 5.0 at 18:05 Universal Time. Yesterday evening, and here are the rest of the quakes over a 5 magnitude. Northern Peru had a 5.1 at 4:57 Universal Time. Yesterday this morning, actually 4:57 Universal Time this morning, Northern Peru had a 5.1, and a 5.2 came through while we did show prep. That would be at Vanuatu, and that came through at 10:05 Universal Time. And it's time to get back to space. So here is another one of our favorite composite wavelengths. This is the past 24 hours from SDO. You're looking at 131 and 171 angstroms together there. Those are both ionized iron species. And the 10.7 centimeter radial flux is now only at 151 solar flux units. So, but don't break out the Bacardi 151 yet. It's going to be up higher today, so we can expect an increase in the radial flux by tomorrow's daily space weather video. There is the one-year graph of the radial flux represented by that black line. The red line below it is a sunspot number. And the space weather enthusiast dashboard here. This is NOAA's forecast, not expecting anything except a little bit of geomagnetic unrest. So there is a possible coronal mass ejection impact. And it looks like NOAA must agree with our forecast there, because there is a possibility of a weak impact late tonight. So just, the 3 hours before midnight tonight, there may be some geomagnetic unrest. We don't expect it to produce any strong aurorae at mid-latitudes or anything like that, but there may be a little uptick caused by a diffuse coronal mass ejection, possible impact. Again, it will be minor. And speaking of minor, let's look at the magnetohydrodynamic pressure in the Earth system for the past 4 hours. So this depicts magnetohydrodynamic pressure. This is our geospace magnetosphere movie. And we've been seeing a weak solar wind. You should see that intensify a little bit here and look a little bit more normal. Again, that's the last 4 hours of Earth's magnetic moment from space, depicting magnetohydrodynamic pressure. It's the geospace magnetosphere movie for the past 4 hours. Here's Earth's magnetic moment from the ground level, depicting magnetic flux density, the units of which are nanotesla. So in the event of major geomagnetic storms, this will show you the most likely places to see the aurora, pipeline, railway, and power grid induction. At the moment, it is a geomagnetically calm situation on planet Earth. There are the likely locations for telluric currents over the past 4 hours. And the KP index is currently at 1. Again, a geomagnetically calm condition. KP1 is the current scenario. And for you new viewers, the KP index is a global average of geomagnetism. Next, our real-time solar wind data, dropping below 400 kilometers per second here. The real-time solar wind depicting 382 kilometers per second for the solar wind speed. Solar wind density here less than 1 at 0.69 protons per cubic centimeter. A very diffuse solar wind speed indeed. So if we do see any signals from a CME impact tonight, it should be quite obvious in that extremely weak solar wind telemetry. Next, the GOES magnetometers here, and they're fairly smooth here following the subsiding of coronal hole high-speed winds. We're back to just a sort of a base level here of solar wind. So that should be great for signal detection. GOES magnetometers here just in a sort of a normal range. And let's take a look at the heliospheric current sheet. So this might be the most important data that we show on the channel. And what's very important about this is we are forecasting a solar uptick, which will be proportional to the migration of this system. So you see that green blob right there at the north heliographic polar region. You see the way it's starting to look unstable? Well, once that suddenly snaps away from the north heliographic pole, you can expect us to rapidly reach solar maximum. So if it's starting to look unstable, it's probably because it is. That magnetism needs to leave the north heliographic pole. It will eventually be replaced by south pole magnetism as we get closer to the next solar minimum. But you can expect similar levels of solar activity that we see today for nearly 2 years in the future. That is the top view ecliptic plane field plot. It's derived from ground-based magnetometers and magnetometers on stereo A and stereo B. This is stereo A here, stereo B over there. There's the latest image. And again, you can see this magnetism here looking like it is getting increasingly unstable. We are expecting that to snap away from the north heliographic pole basically at any moment, at which point we will see activity rise. In other words, more sunspots, higher radio flux, more coronal mass ejections, more solar flares, and more aurora visible here on planet Earth. Here's our line of sight field plot. Earth has just moved into a North Pole-oriented current sheet, and you can actually see the sector boundary crossing right here depicted by the solar B field, which is the blue lines. The sun's B field, the field that goes through the magnet, this magnet being the sun. And let's move to our coronal hole line of sight field plot. There you go. And the coronal holes that are currently on the east side of the sun are of South Pole orientation. So let's take a look at that. So we're going to bring up, there is 211 plus 171 angstroms. And you can see very well-defined coronal holes there in both hemispheres there, rotating right into the Earth strike zone. Coronal holes are the source of high-speed solar winds, and both of these might be geo-effective. This one is a little more likely, but this is a big coronal hole, and keep in mind it might not be completely clear the exact direction that those high-speed winds are coming out. In other words, those high-speed winds could be coming out like this, depending on various factors like magnetic field orientation. Anyway, here's just 211 angstroms by itself. You see those very well-defined coronal holes, and let's move to sunspots. Again, we did see rapid growth. In fact, we're going to see a new group named right here. That'll be 3317. There's another one down here. That's 3316. That also grew. This one down here does not have a name yet. That'll be 3318, and then 3319 up here in the northeast. It is a significant conflagration of new umbral space as the likelihood of major flares rises. Like we said earlier in the video, as sunspots get closer to the limb, they become more likely to produce major flares. So here's 1600 plus 1700 angstroms. And let's zoom in a little bit closer to show some of the spectacular details that we have for you today. So there is the western limb. I would note sunspot growth up here, significant sunspot growth down here, and significant sunspot growth down here. So that's pretty serious. Also, this new group that just rose, this area up here is a plage. We didn't see any ombre when we did show prep, but we'll give you an update on that toward the end of the space weather portion of the video. The new sunspot just rose right down here. We put an Earth scale close to that to give you an idea of the size of it. It is approximately the size of planet Earth. We've also got that same imagery, or that same angle, in the SDO-HMI continuum instrument. Let's briefly take a look at the full disk view here. So we should have an uptick in the sunspot number and the radio flux by the time we do tomorrow's daily space weather video. Meanwhile, the likelihood of major solar flares goes up, especially as these large groups in the northwest set closer to the limb. These groups over here are also more likely to produce larger flares as they're closer to the limb. Next, we'll get to energetic particles and solar flares. And when it comes to energetic particles, we ain't got none. The ghost proton flux here remaining flatline for the past 3 days. The past a lot longer than that, actually. It's been over a week since we had any solar energetic particle events, and frankly, we're overdue. There is the GOES X-ray flux, which is in a low C class level. X-ray background flux is 1.03. C 1.03 is the background X-ray flux. There was one M-class intensification yesterday. It happened while we did our show. Yeah, that's a thing. So here are some 24-hour images for you. That's the 94 plus 131 angstroms wavelengths. Most likely places to see a large flare would be number 1 up here and number 2 over here. Those are my picks where you could expect to see large flares, like M or X class flares. And let's move on to taking a look at what's going on overhead. Now, our star chart is from skyandtelescope.org. We like to orient our viewers a little bit before we start talking about the trajectories of coronal mass ejections and things. There was one spectacular coronal mass ejection to cover, but this is what's going on overhead at the moment over Lehigh Valley, Pennsylvania. Betelgeuse just rose. Anyway, here's your solar system forecast. We'll give you the 1 week heavenly bodies forecast. This is where things are today. And that's where things will be on June 5th, 1 week from today, which is, I believe, full moon. And let's talk CMEs. One happened right around midnight Universal Time. You may see that coming out of the northwestern limb, which would be over here. And I guess it just happened right before midnight, as it's not really visible on that imagery. But let's take a look at today's images as well. There are today's, and you can see that multi-layer coronal mass ejection. So another great example here. This one doesn't look like a bubble or strings. This one looks like a series of overlapping sheets of plasma, which is another scenario that happens with coronal mass ejections. They take various different shapes, and that does affect how they would impact if they were earthly directed. Those don't appear to be earthly directed. So here's Alaska C2 and C3. We'll also show stereo A to show a slightly different angle on those CMEs. And we show this diagram daily because stereo A is overtaking the Earth, and so is stereo B. So Earth is about to blow past stereo B and vice versa, and stereo A is about to slowly overtake the Earth. As stereo B is going this way, and stereo A is going this way. We shared a video about this a couple days ago in our community posts. If you want to see an animation of the orbits of stereo A and stereo B, check out our community posts on YouTube. And if you're viewing on BitChute, if you aren't subscribed on YouTube, you are missing most of the content. So here's stereo A on the left, Soho Lasco C3 on the right, and you can see that multifaceted coronal mass ejection there from the northwest. We'll let it play all the way through, and then we'll show you our custom coronagraph videos, which are better than the, quote, competition, end quote. What I mean by that is there is no competition in the realm of daily space weather. So here are our coronagraphs, starting out here with the SDO 193 angstroms, Soho Lasco C2 and C3. Here's a little closer view. Another spectacular CME there being depicted. Not likely to have any earthly directed components. It's been quiet for Earth plasma impacts for quite a while. So keep in mind, it's not a matter of if, but a matter of when. And let's get back to our data sets. So next thing we're going to show you here is filaments. As we talked about at the beginning of the video, there are a massive number of massive filaments currently littering the Earth-facing portion of the solar disk. You can see one saying bye-bye right up here, right there. Oh, there it goes. This one down here is probably the densest and most massive, although this one here is huge. This one down here setting in the north and in the southwest is huge. That is the ground-based hydrogen alpha telescope at Udaipur, India. Likelihood of coronal mass ejections, 100%. Let's just say 100% once again. Expect some fireworks today. We'll make sure that we stay on top of it and provide the most detailed imagery and comprehensive space weather that you'll find in the known universe. We're almost to our bonus features segment. First, let's show you the 193 angstroms wavelength in full disk glory. It's good at showing coronal holes, active regions, plasma filaments, and the extended corona. And let's take a look at that's a 24-hour video, by the way. Let's take a look at the past couple of hours. By the way, that spectacular CME that came out of the northwest, that was from this area right up here. Right there. The CME happens just before midnight, I thought. It was a pretty modest plasma orientation happening there. Not a big signal associated with that. And let's take a look at the past couple of hours here from the GOES SUVI. So a number of unstable looking filaments here and high likelihood of solar flares, growth of sunspots. It's what you call a major solar uptick. something that we like to see. Fingers crossed for additional exciting space weather happenings. We'll make sure that we cover it in the full, spectacular detail here at the Smash News Network. Least busted name in news. Next, bonus features. Space Weather Enthusiast dashboard not showing any charging hazards. It's smooth sailing for satellites, unlike yesterday and the day before. The GOES electron flux here showing some little lower levels here, just in sort of a normal operating range there. I think it's on the low side, but let's take a look at a one-year chart. It's right in the middle of the operating range. That is the one-year graph from Solon.info of the relativistic electrons. There's the forecast model, and I would tend to agree with that. No arguments from me there. The green boxes are the forecast. The yellow diamonds are the observation. Next, we'll show the layer of the ionosphere where that electron flux is measured using radiography from tens of thousands of miles higher, where the GOES 16 and GOES 18 are located. This is the vibrational frequency of the F layer, which is at about 300 kilometers of altitude. This data is in megahertz, millions of vibrations per second. And we're seeing primarily low-frequency anomalies once again in the ionosphere. This data is courtesy of Australian Government Bureau of Meteorology. We'll show the anomalygram as well to clarify this. There is the anomalygram. Low-frequency anomaly shown in red, high-frequency anomaly shown in blue. It's the anomaly in megahertz from the 30-day median. It does show additional resolution. 100 times the or 10 times the resolution at least. That shows a tenth of a megahertz change there. Part of the reason why we show it, here's the latest image. That is 12:15 universal time for the ionogram and 12:15 universal time for the anomalygram. Most of those low-frequency anomalies happening there south of the equator. We'll also show the total electron content. That's the free electrons to about 12,500 miles of altitude. Feel free to pause the video on this frame if you're not familiar with distances of those things in miles. Here is the total electron content on a global scale. This will show you the most likely places for GPS errors, as those free electrons can cause signal refraction. In fact, the signal refraction is what's used to calculate where those free electrons are located. This is literally a count of the free electrons, the total electron content forecast. We'll also show the total electron content anomaly from the 10-day average over North America. There you can see some low electron content anomalies over places like the Eastern Pacific, the Gulf of Mexico, the Caribbean, Central America, Mexico. High-frequency electron anomalies, not so much. That's the total electron content anomaly from the 10-day average for North America. We'll close out the space weather section with the latest intensitygram and latest colorized magnetogram. And it looks like we may indeed have a sunspot up here. I think we do. And nope, not yet. Let's try that again. So there is the intensitygram, no dark umbra showing up on there. And there is the colorized magnetogram. You can see some magnetic organization rising. This new sunspot, so far, it looks like it's only alpha class, folks. So I only see one field there. Here it is in colorized magnetogram. Only one sunspot there. So it's not all that likely to produce a large flare. Looks like another active region rising down here, and I think that one does show ombre. Let's check it out. Is it a bad ombre? Yep. So there's another sunspot. So we have like 5 new locations where we're seeing sunspot activity here. It's not just a solar uptick. It is a major solar uptick happening suddenly enough that the, quote, competition when it comes to space weather is going to be looking for ways to convince their viewers that the sun is shutting down or something. How busted, hey Talc, you are more out of gas than a Tesla being charged by a solar panel. Let's move to our meteorology segment. The windiest place in the world, just northeast of the Philippines. So there you go. We've been covering it. It's been loitering, actually, since yesterday. It hasn't moved very much, but it has broken down a bit. So the winds have dropped in their velocity. We won't spend too much time worrying about that. These are the surface winds of the eastern world. And by the way, if you think the planet's overpopulated, shout out to David Dubine. If you think the planet's overpopulated, then how is it that over 2 billion people fit into this relatively small area? I mean, look at that. That's like the size of Australia. Yet 2 billion people live there. Yeah, the planet. It's so overpopulated that it could sustain like 10 billion people without batting an eyelash. Anyway, I guess that was controversial enough. Here are the jet streams of the eastern world. And if I made you mad with that obvious fact about all the natural resources that aren't being exploited or used in any sustainable or reasonable way, or the misallocation of existing resources, then make sure you leave us a comment and make sure you tell us what a jerk I am. So those are the jet streams. Here are the jet streams of the central world. That's Africa, Europe, and the Middle East, which is, I guess, a term I'm not supposed to use. It's now called Central Asia instead of the Middle East. Whatever. And here are the surface winds of the central world, surface winds of the Americas, jet streams of the Americas, still incoherent jet streams over the U.S. Check it out, folks. Jet streams are all over the place. We've got this low down here over South Carolina. We've got a anticyclone here over Lake Michigan. You can see a clockwise rotation there from that high pressure zone, an upper level. You can see a divergence of the jet stream over here in the west, maybe because of all of the hot air that's coming out of Colorado. And yeah, so quite an incoherent jet stream here over the U.S. This will do things like make your weather systems move in odd directions, as opposed to typically you'll see weather systems move from west to east. So here we've put up the soil moisture anomaly map. I just wanted to show how dry it is west of the Mississippi Valley, except for the southeastern U.S. Quite dry there in places like Missouri and Iowa, also Pennsylvania, New York, and New Jersey. Like 2.3 inches behind as far as rainfall. And let's briefly take a look here at the pressure over that cyclone by the Philippines. So here's your pressure map. And let's cross the Pacific. And that is probably the lowest pressure in the world, although there might be some pressure in the Southern Ocean that's similar. It's at 958 hectopascals. Again, it has weakened since yesterday, and let's move on to our clouds and fog map for the Western world. No, it's not Adobe Photoshop, and if your favorite flat Earth pals on social media would like a photograph of the planet, well, there it is. It might look spherical. Yeah, water always finds its level, whatever that means. It finds a level perpendicular with the source of gravity, a feature of basic nature denied by a lot of, shall we say, imbeciles on the internet. Here's your weather.gov map. If your location's lit, click your location at weather.gov, the official website of the National Weather Service. We've shown you the key, and we're going to show you forecasts also. Weather.gov. Since you're viewing this video on the internet, I'll bet you could visit a website such as smashomash.com. Here is the 72-hour GFS temperature anomaly forecast in degrees Celsius. You can see some rather rapid variations in temperature here. And we only show the 72-hour forecast because why? It tends to be accurate. Yeah, accurate. And as far as making small forecasts in localized locations in all of those areas, we can do it. We hope you can too. Understanding basic atmospheric physics would really help people to be able to forecast their own weather. That's why we give little tidbits. Here's the temperature forecast based on the same GFS 72-hour model. These temperatures are in degrees Fahrenheit. That's your 72-hour GFS temperature forecast. And we've also got the GFS 72-hour pressure and precipitation. So that's the first half of your week. We'll also show lightning to show you where the storms have been. And let's don't forget to show you where the storms are. So here's a real-time lightning map courtesy of lightningmaps.org. And a heavy amount of lightning here north of the Mediterranean. Check it out. Yowzers. A lot of lightning there. It looks like it's a bad day to immigrate to Europe. Anyway, it looks like no terrestrial strikes over the U.S. Let's close this thing out with U.S. Doppler radar, the clouds and fog, and the water vapor map. So there is vertical motion of water droplets and ice crystals in the air column. The ground-based Doppler radar systems. We'll focus on the lower 48 for the remainder of the video. Here is clouds and fog. You can see that strong low there rotating over western South Carolina. It'll be even more obvious in the water vapor map. Right there, a perfect example of a significant low pressure. What's causing it to not be so strong is that there's barely any moisture in it. It's all dry mass of air surrounding it, which does not aid in convection. Also cooler temperatures, not helping to drive that into massive pressure gradients. Anyway, here's your recap. U.S. Doppler radar. Clouds and fog, represented by the 3.9 micrometer infrared radiation satellite. And last but not least, water vapor, which is 6.19 micrometer infrared radiation. Thanks for tuning into the Smash News Network, least busted name in news. Hopefully we brought you some facts. Hopefully we've debunked some nonsense. It's something that we're big on the channel. Anyway, we'll see you soon. Universum liberate. And may that solar wind be at your back. It's bunker time, baby. Bunker time. And it's just the right depth, folks. Just the right depth. Woo!